Okay, my friends, you know that I have been talking a lot about light and the speed of light and how we can measure distances in what they call a vacuum of space, which is not a vacuum. And light does not travel at the same speed. I will show you this in pretty good detail, actually visualizing, seeing the light and seeing the fields that are in space which impede light. Regardless, there is no vacuum in space. Okay, so why would I claim I know what light is? Well, Fermilab is saying these are the smallest particles they can find. This black one has all the mass with a glowy edge around it. It has no mass, but it has a field around it. This is Don Lincoln at Fermilab. Not only does he say this about light particles, being these are the smallest particles they can find, he also says this, that there's a quantum foam in space, and empty space isn't empty. First of all, it's not empty because of all of the particles that are out there. He says it's like the foam on root beer, and it just keeps blinking on and off, all these little particles. Yes, because they're just particles that are out there. Light has slowed down to a point where it's just sort of floating around, and every now and then it gets whacked and they blink. That's all it is. That's what quantum foam is. And that's what the particles are, and these are the particles that we found, the exact same particles. The black one with the glowy edge around it, this is right from his thing. This was 12 years ago, I think now. And I got a hold of Don, I said, we found your particles, and it just didn't go well. You know, they don't like to have somebody step on their toes. I didn't mean to step on anybody's toes. I'm just saying, you know, we started with light. We didn't have to start with these big particles you guys are using. And they're getting just debris, and they're sorting through the debris, and they're finding these particles, yes. Why not start with the particles like we did? The little ones, we started with those. That's light. That's not the things they're using. They're using like bombs. This is light. And then there's light accelerating. That's light coming out the other side. It creates Higgs fields. But they're Higgs fields going in. Higgs fields is nothing more than a light wave. That's a Higgs field. 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 They're everywhere. All they are is light. You can put your finger up in the air like that in the sunlight and create Higgs fields. I'm not kidding you. Okay, I have a lot of people recently been telling me to reach out to Terrence Howard, which I am trying to do. And if you can do that, I would. They say he wants to talk to somebody about his theories. I'm not exactly sure what, but I know he had some theory about the periodic table. I'm perfectly willing to talk, because if my theory is right, it's a dramatic shift. A radical shift in our understanding of the building blocks of matter, focuses that govern their interaction. If proven correct, it would necessitate a complete overhaul of many current physics theories. Literally everything, 100%. And that's my theory. They know this, and you know, this is not something that's unknown now. Dipole electron flood proposed by Roger Spurr is correct. That's what they should say, not is it. It is correct, and this is, I'm showing it's correct. I have the evidence, not just theories. Now, before we get started too deep here, I just want to tell you, they're starting to understand dipole electron flood theory. This is from AI. Dipole electron flood theory proposed by Roger Spurr is correct. If dipole electron flood theory proposed by Roger Spurr is correct, it would necessitate significant revisions to our understanding of fundamental physics, particularly in atomic structure and the nature of matter. It's just not understood now. The dipole nature is not understood, and they say it comes down. They did a nice presentation of what I claim. And it says, in essence, if dipole electron flood theory proposed a radical shift in our understanding of the building blocks of matter and the forces that govern their interactions. If proven correct, it would necessitate a complete overhaul of many current physics theories. And it's not if, it is correct. And this is not something I just came up with. These are all experiments and stuff I did 50 years ago. All about the power and amps and heat and the conversion, how things are converted, and I mean, it goes on and on and on. Rapid oxidation. Now, what I came up with was this. This is the most important part of everything right here. Transfer of energy is from light to atomic vapor. Atomic vapor means you have little tiny particles, which is the dipoles. That's the atomic vapor. You condense that and you end up with material. Well, what's the first condensation of a dipole electron? It's a photon, which is two dipole electrons together. And then they don't get stable again until you hit about a proton, which is up in the range of about a hydrogen atom. And that's got 1,840 dipoles. So my point here is this is not something I just came up with 10 minutes ago and oh boy, I just figured this out. No, everything there was two types of intermolecular forces. Dipole interactions. There's polar and there's non-polar. This goes way, way, way back. I mean, and they tried to destroy me in physics because everything I was talking was dipole moments, polar molecules, because everything has a dipole moment. There's always this polarity to everything. There is nothing that isn't magnetic. Gravity is magnetism. Gravity is magnetism. The Earth is the dipole part, the dark part. We're standing on dark matter, literally. I'm serious. I'm going to show you. We need a complete overhaul of everything that we've been taught, and I'm going to show you why, and you'll see it. If you can dismiss what I'm saying, I want you to talk to me about it. See, this goes back quite a while ago. These are the same point particles Fermilab found, and we found them too in our experiments. I got a hold of Don Lincoln at Fermilab, and he wasn't happy about it. So I've been put on the do not disturb list. Okay, my good friends, what are we seeing here? We're seeing experiments and illustrations of what light does and should look like, and colliders, how they create particles. They call it a particle zoo, all these things. And these Higgs fields. Let's start with the Higgs fields, because this is going to be very, very informative. These are Higgs fields right here, these little circular patterns. Rod Warren and I did experiments years ago, over 10 years ago, using lasers and colliding them through Venturi into just open space, and this is what they create as Higgs fields. Now what they did at CERN is they took particles and crushed them head on, and they got these Higgs fields, but they're sort of splattered everywhere. We directed them through the Venturi, and here's how this works. In the big particle colliders, they take huge things and they smash them together like big, big, big particles. Think of it this way. They take protons and neutrons, bam, and everything just goes flying. And they see these Higgs fields patterns. And this is from, I can't remember whether this is from CERN or Fermilab, but I believe it's one or the other. They all have their own little representations. This I think was from Atlas Lab, and this I know was from CERN. But this is what they see. But they see so much debris. They can see the fields, but they're just in a clutter of debris. We don't have that debris because we didn't start with big, big, big particles like this. We didn't start with those. We started with the bits and pieces of these. Think of it this way. That's a proton, that's a proton. Well, they always thought a proton was just a big solid chunk and you could smash it to bits, but they didn't know what the bits were. That's why they're doing this. They want to find out what the bits are in here. Well, I can show you what the bits are. The bits are light. Anytime they ever have a collision, they always get light. Light is always, that's any explosion whatsoever, you get light. Light is this. All right, well, it's actually two of these. We started with this. We started with light, so we don't have to look through any of this. we can look at the actual particles, and here are the actual particles. This is actually a particle of light. They call it a photon, and this shows the energy values within the photon, and this is moving this way. This part of the white electron neutrino is charging while this one is discharging, and this will charge up and then it will flip, that one will come front, and they just keep flipping like that. That's called a muon wobble, and it is because this one is concussing with the particles that are in front of it. That is a particle of light. So we're down in this range here. All right, they're in this range here, which is a gigantic thing. When they hit these things together, they just get enormous blobs of gook. And these are what the blobs of gook look like. They come like this. Bam! And then just everything goes everywhere. And they don't know where it started because they're just seeing chunks. They see the same things we see. The red, the green, and the blue, and they see the photons, but then they see these big X chunks or big chunks like this. They see debris everywhere. We don't have to go through that. We have started where they want to get to, which is the muon and electron neutrino tied together make a photon. When they hit the Venturi, they separate. And this is the Venturi right here. The particle was there creating a wave, because just as this has a wave around it, you see those two magnets there? There's a wave around each one of these, and when their waves hit each other, they don't want to be next to each other. You don't see anything there. But there is no vacuum there. There's something going on between these magnets. And it's because of their polarity. So right now, we have negative pushing negative. These right here. If we turn one over, now we have a positive attracted to a negative, and they stick together. You see, and they stick together tight. You see that? Now, if I turn one over, ooh, they want to be attached to each other. All right, but if I turn one over, it will stay away from the other one because it's now pushing. The white is pushing the other white away from it. That's why you get these, what they call interference patterns. They're not interference patterns. Those patterns in the back there are separation patterns. That's this one saying, you get away from me, I'll get away from you. So we can set up a distance right here. That's it. You see this one trying to snake away? That's the distance. That's where you get these right here. And they set up a distance that is just fabulously perfect. You see this? They call this interference patterns. They think you're getting all these different little stripes out like this because the waves are flapping like this. They are not. Light spins in a circle. It spins this way and it spins that way. That is a drill bit. And these little interference patterns, they call them, are nothing more than push to shove. It says, you stay away from me, I'll stay away from you. And we'll stay exactly at a distance because it pushes this one, it pushes this one. And they're just absolutely unbelievable. And you see how it's down here and it's up here? That's because of the drill effect. On this side you see almost nothing, on this side you see almost nothing, but this is where the impact starts. And that's where the impact starts. That's why you see it this way. And that's coming through the Venturi on a back wall, and it spins this way. Here's what a light particle is, just like this, it spins. The particle's there, and it spins like this, and spins all over the place. There's a whole bunch of them. So when they come through here, most of them come through the middle, but some come this way, some come that way. But they all spin right hand. Now, I do have one that did not go right hand, and this is the one I'd like to see physicists take a look at. I'm going to do another video on this, the most crazy particle I've ever seen. Nobody's ever seen one of these before, I don't think. All right, this is really crazy. This is where the light accelerates. No question it's accelerating. And this is where the particle begins to show itself. Other than that, there was just a big field surrounding that tiny little particle, just like there was a big field surrounding these particles. As it accelerates, because of the Venturi, it just pulls itself right out of its own field, just like breaking the sound barrier, the speed of sound. You know, with a jet fighter, boom, and they break right through that wall. Well, this is broken right through the wall of light. And here it just explodes. Now, coming out the other side is where we had all those interference patterns. But also we have an extreme blast of white. And then all of a sudden they create their Higgs fields. You see the Higgs fields showing back up here? Let me show you that in some great detail. All right, the Venturi's up here. This is coming down, and all of a sudden, it splatters out into light fields, which are the Higgs. And they create these Higgs, these little white particles. I believe, now this is just my theory because I'm seeing what I'm seeing. I'm not just guessing, and I'm not drawing illustrations and using computers to figure this out. I'm actually watching light come through here, separated from the black part. Now, some blacks are jumping in. You see them? There's black parts jumping in here and there. And all of a sudden, at a certain distance from the Venturi, it's like hitting a wall. And they just splatter. And this one here is probably the best example I can give you. You can see the white is going, and all of a sudden you see the bing, 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 bing. And then it just starts to create the circle, which is the Higgs field. Now, the craziest, and they all do the same, every one of them. I've never seen any other than this, except once. That's the one I'd love to see physicists try to figure out. I know how it happened, but I don't think they'll ever figure it out. We're going to find out. All right, just a quick overview of the whole thing. This is the light pulsating red laser. The only reason you can see this at all is because it's beginning to accelerate. There's much more particles of this exact same nature are right in here, all over the place, but you don't see them because this one's directly in line with the Venturi. These same fields here are in here. They're coming along with this one, but this one happens to be directly in line with the Venturi, so it accelerates that exact particular particle. These are here. They're here, they're coming forward. You just don't see them because they're not accelerating. The only time you see light in this is during acceleration. Now, in the extreme end of the acceleration, it pulls itself right out of its own wave, and here's where it concusses, and the black splits from the white. And this is where the showers occur, and right there is the abrupt transition from the white into material once again, which is photons. And when I say the two particles, the black and the white, these are those particles right here. They're coming this way. And they're stuck together. That's their nature as a photon. And here they're still stuck together, stuck together, stuck together, stuck together. Boom! Now the black separates from the white. And they actually physically separate. This is looking into the Venturi. So we will be looking into this. The light is coming here, and all of a sudden these Higgs fields start to show up. Boom! Now one of them was an anomaly right here. That one right there is the only one I've ever seen like this. And that is an anomaly, and it involves the two Higgs fields together. And this took me 3.5 years to figure out what caused that, and I think I have figured it out. But I'd like to have some other physicists try to tell me what their explanation of that little tiny field is. They know the Higgs fields are everywhere. They know they're everywhere. They see them, but they don't see them like we see them. They see them in a ball of debris. That's all. They see these little fields and they say, wow. And they know that the blue, they take off. Hold on one second. Where is it? All right, well, here it is right here. There's their collision. For them, it's this. boom, and everything goes flying. Well, why do you have blue, and why do you have green, and red, and yellow, and all these other colors, white? And why are these just gone and they don't come back, and the red sort of just hangs around? The reason is the red is loosely held. Let me show you what a photon, actually a proton, looks like. They're slamming these things together, boom. Well, a proton is not what they think it is. They think there's a few quarks and so forth, and if they smash it hard enough, they can get little bitty bits and pieces. They can get little bitty bits and pieces every single time. It's just they don't know what they're getting. This is the point of collision. Now watch this. Okay, here's what they say. The smallest particles there are in physics is often used to refer to fundamental particles, which are the smallest. The fundamental, they're the small, elemental. Dirac and Majorna neutrinos are both fundamental particles. They're both fundamental particles, so they're the smallest particles there is. And these are the Higgs and the Majorna. They're black and white. And when they're in flight, they're not quite black and white. They're sort of half in and out. And I show that as well as the actual photon Diracs. And this is when, hold on here. All right, here it is right here. This is red. Undusted. Now, the red light is coming this way, the laser. Here is what you would call the Majornas. They're neutrinos that are not fully fledged photons. That's a full-fledged photon. This is a Majorna, that's a Majorna. These are different flavors, they call them. This is the sideways, this is the up and down. This is the photon, which is the black and white particle stuck together in that four-way configuration. Here it explodes and divided. The only reason we can see this photon out here is because of the reverse electromagnetic force. They call it reverse EMF. Pushing this way, as this one's pushing this way, it thinks it just hit a wall right here. That's why it's showing up as a photon. They don't show up as photons until they bang into something and pop back. They're always in the neutrino phase until they actually concuss. And that's my opinion. I'm almost certain of that now because I have seen it over and over. And when they concuss, the black leaves the white. Now, you can have green, you can have blue, you can have red. We see the exact same thing in the green and the red. The blue is a little too fast to see, but I'll show you the green displaying the exact same photon. And that is the particle. That is what a light particle is. And that light particle has a wave around it about like this size. It's big. And it pushes everything out of its way in front of it because of the field. Not the particle, it's the field. And the field seems to have no mass to it that I can find. All right, there's the green ones coming through. Same way. They come through with the Majorna and then they turn into the photons. It's just a much faster, and I can show you it's faster. You see this? These are both the photons coming through. The red laser is at the bottom, the green is at the top. They are concussing with each other, and the green is much more powerful and just pushes the red out of the way. And not only that, it makes the red barrel roll like this. They don't do that. They always go this way. They never go that way. I don't think anybody's, I'd be surprised if anybody's ever seen them barrel rolling. They usually call upspin and downspin. This is round spin. Now, the green reconcusses way back out here again because the screen is much more powerful and it's going much faster. It's pushing the white ones, the white part, to go this way, so it's pushing past it. So the green must be going slower, in my opinion, than the red must be going slower than the green. So the green, get out of the way, and the red rolls away like this. The green starts rolling too here and there. But primarily the red just gets pushed out of the way and just rolls on down the hill. That one, just keeps right on going. Green is much more powerful than the red, and the blue is much more powerful than the green. Now this is with the Venturi and the red. And you can see it's completely separated. Black is 100% separated from the white, 100%. And then it recombines right out here. At a certain distance, it will just try to recombine. And that's when the Higgs fields show up. Now this is the green. It's a much more powerful than the red. So we can separate it. And you can see the black is coming off to this side. Only black particles are here. There's none here whatsoever. We're looking into the Venturi here, seeing the spray come out this way. The black is going off this way, and I think I understand why. It's because of the pins of the Venturi were not exact. So all the particles ended up going this way, because they are the particles. These are actual particles. The white is just a field. It creates these big, huge fields. You see that difference? You don't see it over here, you see it over there. It's like splitting between the fields on that side and the particles mainly on this side. That's what I'm seeing. And I'm sure that's what you're seeing too. All right, you see this? It's saying the smallest particles refer to fundamental particles, both Dirac and Majorna. They think they're two separate things. Dirac and Majorna neutrinos are types of fundamental particles. They call them leptons, but they are fundamental particles. Now, the Standard Model doesn't explicitly define a smallest particle, but it does classify particles as fundamental, which means they're just one piece, or composite. Actually, Dirac and Majornas are not fundamental. The particles that make them up are the fundamental, which is the neutrinos, the muon and the electron neutrinos specifically. All right, here's the deal with neutrinos. Neutrinos as fundamental. Neutrinos are considered fundamental particles in the Standard Model, meaning they're not believed to be made up of smaller particles. They're supposed to be the smallest particles there is. Now you have Dirac and Majorna neutrinos, which I have shown. The debate about these neutrinos, are Dirac or Majorna particles, centers around whether they are their own antiparticles. They have this backwards, actually. This distinction is important because it affects their properties and how they interact with other particles. Yes, and they have this backwards. They're saying it's the Dirac or Majorna particles center around whether they're their own antiparticles. Let me show you what they say about particles versus antiparticles in these particular neutrinos. So what about photons? Are they fundamental? Well, yes. Photons are considered fundamental particles in the Standard Model. The Standard Model doesn't work. I'll show you the one that does work. Is Dipole Flood Theory. Dipole Electron Flood Theory. Now, they are quanta, which is the smallest little package of electromagnetic radiation, meaning they are the fundamental units of light. Well, yes. And other forms of electromagnetic waves. Exactly. Sound is a photon. It's just very slow. It's an electromagnetic wave. Photons are massless and travel at the speed of light. Incorrect. They have mass and they travel at all kinds of different speeds. Now, I have shown you that these photons are light. The light comes from the laser. I showed you this light. That is a photon. There is no dispute about that. There cannot be a dispute about it. This is what comes out from a red laser. And if you look up a red laser, is that light? They'll say yes. Is that photons? They say yes. And that's what it is right there. And here's how the whole thing started. The light came through here, started to accelerate, all of a sudden it starts to glow. Then it rocket ships through and crushes in the Venturi, and only the white can squirt through. The black gets pushed back. Coming through the Venturi this way, the white interacts again with the black particles and turns into Higgs fields. It's not, they have it the other way around. They think the Higgs field is the God particle that creates all these other particles. No, the Higgs field is when it comes back together, not when it separates. And then you got this baby here. That's what I want to hear from CERN. I want to hear from Fermilab. I want to hear from Lawrence Livermore. I've been interacting with all these people. They just won't step up to what they're supposed to do. They should be asking me, how did you do this? How did that happen? What are you seeing? What's going on? Not a single word. Zero. This is space. This is not a vacuum. There's absolutely no way that's a vacuum. And all of these are magnetic fields, and they push other magnetic fields, and light is a magnetic field. Light coming to us from the other side of the galaxy, or wherever they're saying, it slows down. It's not being stretched and pulled away. That's why it's turning red. It's just slowing down into a lower frequency. So it's coming way off of these stars or whatever, or real high frequencies, and it comes through all this stuff. It goes boom, 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 and then it just keeps going down. And sooner or later, it gets down to red, and we see it. Say, "Ooh, look, it's pulling away." No, it's not pulling away. Light is not a one-set speed. It's just, Einstein ruined science for 100 years with that nonsense about the speed of light travels, and then there is no vacuum in space. Speed of light may go the same speed in a vacuum. I can't disagree with that, because there's nothing to slow it down. You throw something through when there's nothing there, it just would probably go. But there is nothing that is nothing, because everything is something. There is, and even if you look up Fermilab, they said there is, look up the quantum foam, there is no empty space anywhere. They call it like the head of a root beer, flicking on and off, because the particles are all out there. It's like bang, 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 bang. They're lighting up. That's what you see is the glow of the universe, is the very, very, very slow particles that are down here where you can't even see them. They're not light at all. They're getting banged, banged, and banged, and then they show up as light, a little bit of a glow. There is no empty space. The Webb telescope is not doing its job. It cannot possibly tell where we are and how far these things are away. It's impossible. Even if space is not homogeneous either. So there's big clumps here and littler ones there, and they have no idea how far things are away. Absolutely none whatsoever. All right, there is some beauty that they can do with these shots and looking out in space. And I see I believe that's almost like an atom. Oh man, it just never changes, it never ends. I just came across this just a minute ago. I had seen this years and years ago. I think they called this an Einstein ring. And, my dipole electron flood theory does predict something very similar to this, only almost backwards. The white should not be in the center. The black should be in the center. But I did see something that really turned me on. There's like layers. There's white, and then there's the yellow, then there's the black, and then there's yellowish again. And some of the black intrudes through. And where it does, it sends out these spikes. The universe is nothing more than just big chemistry. We're little chemistry. The universe is just big chemistry. You look out there, you see all these things, you think, oh, they're just things out in space. No, I'm not sure what they're doing. I got to be honest with you, but they follow the patterns of chemistry and molecules and fields and all of that stuff, which I have shown pretty clearly. All of these things appear to follow what you see in space. I mean, here it is right here. These are dipoles. These are all dipoles. These are all the magnetic fields. And I showed you, these are the kind of fields you get when you take magnets. I should do a whole thing on magnetism and electricity and all that, because it's fascinating. And especially the magnets they have now, they're very, very strong. And you can mold them into different shapes to do different things with them. It's an exciting time for magnetism. And magnetism is not well understood. And light is just not understood at all. It's just not understood. If you took something like this here, all right, nobody understands this. It's been 150 years ago they made this. Nobody understands how it works. I'm not kidding you. Nobody understands how that works. If you think you do, I want you to explain it to me. All right, let's just consider this as scientists, which we are. We have this Crookes radiometer. A Crookes radiometer has these black and white veins in there. And if you shine light on it, it will spin in one direction. And I will show you that. However, it also spins depending upon heat and cold. Cold makes it spin in one direction, heat makes it spin in another direction. What's going on with that? I'm going to show you this in a little more detail in a second. But don't forget, we're talking about light. And light is everywhere in the universe. It's literally everywhere. There is nowhere that you can go where there is no light. It's impossible. And light is particles. So that means that there is no place in the universe that is empty. It's impossible. Light is everywhere. They call it the cosmic microwave background. Cosmic means everywhere in the cosmos. Microwave means little tiny bits and pieces that are way down in the microwave range and they're just barely moving around. Background means they're just everywhere. And so it's not an unknown thing. They just disregard it and spend trillions, literally trillions of dollars on this space stuff that they can't accept the things that they find when they find the things that they find. Okay, photons are light. I don't care what you call them. Photons create light. They are light. That is what a photon is. So what is it, and can we separate a photon of light from the dark part that's attached to the light? They don't know this. Nobody knows this. Dark matter is attached to light. Dark matter is light. It's half of the light is the dark matter. And that is what pushes things. They don't understand it. They think a photon has no mass, there's just nothing there. Yes, light has mass. The dark part is the mass. And I will show you that mass in action right now. Okay, even Veritasium got 17 million subscribers, is why no one has measured the speed of light. Nobody has ever measured it. They just accept it. It's just not right. I'm going to show you a couple of different atomic bomb blasts, which is nothing more than what you're seeing here. This is a subatomic bomb. The black part has come apart from the white. That's fission. When you take the black away from the white, it's fission. When they come back together, it's fusion, and that happens both. Now, the first atomic bomb blast we're going to see deals with this white being pushed by the black. Let me just explain to you what an atomic bomb is. You know, everybody thinks, oh, atomic bomb, big fancy this and that. It's one of the most simple devices on planet Earth. It's just that you have to have a mass that is so enriched that it just wants to fall apart by itself, and I mean explosively fall apart. Then you contain it, and then you crush it, and then it just all goes. So what happens? The black is in the center of all of this mass. There's so many extra electron neutrinos crushed into it that they just want to explode right away. Then you encase it, then you force it together, and then it takes off. Now, what do you really have? You have a ball of particles like this, but there's so many, there's just way too many. And in the center is where the dark matter is. So when you crush this together, boom, what comes out first? All of these push each other and they bounce out. Just like these two right here bounce away from each other. Boom, because you just crush them together and they're going to really take off. If I'm right here, almost touching, you see that? How fast that took off? All right, let's go over that one more time. Just the normal pushing through atmosphere, everything gets out of each other's way. But when you're in a ball like this of so many particles, so crushed together, and then you force them together with explosives or whatever, first of all, they're just like this. They're almost touching. Watch this. They're so tight, they're almost touching. Phew, look at that thing go. Do you see that? They're really, you almost can't make them touch. It's called the Kashmir effect. Now watch this. Now I'm going to explode it inward. Oops. And then it's going to take off like a rocket ship. I can't even do it. I'm sorry, hold on. All right, like I said, an atomic bomb is the most simple device there is. It's just that you have to have the right particles, and then you have to have them in such a mass, and then you have to enclose them and crush them, and then they go flying out. And the first part that comes out is the white, and then the black follows it. The white has no mass, but all the energy. The black has all the mass, and it just pushes the white. I'll show it to you. All right, here's going to be atomic bomb blast. The first thing that happens is just intense white, and it's just vaporizing now. There's nothing moved, not a thing. But we know we have just been pulsed by that atomic bomb blast. But only the white is hitting us because the black is inside the white. So the white has been shot out everywhere. But it has no mass. There's no mass there. It's just a field. Just like there's a field here, but there's no mass to that field. But it's got some kind of energy that pushes the other one apart. And that's what's happening here. And it's infusing into all of the white particles that are here and just combusting, but not going anywhere. It's just fuming up. Look at the poles back here. Look at the poles. Look at the wires. Everything is burning. Anything that can absorb an electron, which invades that nuclear space with energy, too much energy. And they just combust. Anything, and it appears it's got something to do with oxygen, I'm sure. But anyway, that's a whole other discussion. Here's what happens is, as this hits, no movement whatsoever of particles other than just the smoking, which is the vaporizing. So we know we're getting basically combustion. All right, so here it goes. It's just vaporizing. Boom, now that I just stopped it. Here's the black hits. So what happened? The white came flying out everywhere. And it hit the house and just burnt it up, but it has no mass. That's hard for me to understand. I can't. They call it a point particle. It's just it just has a field, and I can see this, but I can't understand it. How could this just push that away? What's pushing? I know they call it a magnetic field, but what is that magnetic field made of? It's just a bubble of something. There's got to be something there. But as I say, in a car, when you fill it up with electricity, or any battery, you put the electricity into it, it doesn't gain any weight whatsoever. None, zero. I mean, almost none. This is where they're not quite on it. They just don't even know. I don't think they know. But a car just doesn't increase weight. When you put the battery, fill it up, then you can drive 500 miles, and this just doesn't. It still weighs the same amount. It never increase any weight. Why? Why would that happen? How could it have that energy? But we saw it. It burnt this thing to shred. It just burnt it right up. All right, just burnt it up, but it didn't move it. And then all of a sudden, when the black stuff came, phew, then it goes. Watch. Boom. All right, so we know we got that. Now, I'm going to show you something else that virtually even the nuclear physicist guys, they don't understand. Whistler waves. I'm going to show you how that works. Okay, my friends, I don't mean to be disrespectful, but this is what they're calling for the Higgs fields, these little drawings. They know that these fields exist. They just don't understand them. I understand them. This is from Atlas, which is part of the Large Hadron Collider. And they're seeing these huge things, and they're seeing all these fields come out from them. Well, yes, that happens. And we see it happen when it comes through here. All those huge fields come out. They're smashing huge things. You can do this, like I said, with your finger. My friend Renz over there in France stuck his finger up in the sunlight like this. And here's the red, blue, green, red, blue, green, red, blue, green coming off of there. Those are the different frequencies of light. And here's the Higgs fields coming right off his fingertip. They're everywhere. Those are nothing more than light. They're They're light. And they show up as a field if you have the right CMOS. CMOS is the key to this whole thing. CMOS is, we use this phone here, Rod and I use the Samsung Galaxy S3. This goes back to 2012. And you can see these, I don't know if it's especially with this phone or with certain phones, but they can see these because of the way the pixels are set up in the CMOS and the amplification. There's a bunch of different little things. You can look it up, CMOS, pixels and so forth. Anyway, whatever it is, light will not damage the CMOS. Light in itself is not strong enough to damage the CMOS. But at CERN, they were trying to see particles with CMOS, and it destroyed the CMOS because the particles they were getting hit with were like this. We never get bigger than a particle like this, never. So it is made to pick up these particles. CMOS in here is made to pick up these light particles. And it does, and works fine. And it doesn't interfere with the explosion or whatever you're looking at. You're just back here waiting for the stuff to hit it. Otherwise, it would just go out into outer space or somewhere. So we're not interrupting. We're not causing any observer effect. We're seeing the actual colors and the light and the fields and everything. And it's strictly because of the way we did it, using the CMOS and using the Venturi to accelerate the light. And then having the light reform back to its own original form, which is here, which are the Higgs. They came in as Higgs too. I never really put this together, I got to be honest with you. They start out as Higgs coming in, you just never see them because they're not accelerated enough to show up. However, once you start accelerating them, and once you push back this way, then all of a sudden they're here. You would never know they're there. You'd never, ever, 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 ever know that. And this one here, the only reason you know it's there because it's hitting the straight, dead nuts right through the Venturi. So that's why this one you can see, because it's accelerating forward. These are just going with the normal speed that they're supposed to, so they just sort of float through the air. Basically, they're going pretty fast, but they're not enough to really push, like get the hell out of the way, like a jet fighter. These things are but all of a sudden, they see this coming back at them, and they say, whoa, and then that's you got your energy. And the particles break apart, and here they come back together. This is a subatomic nuclear explosion. Fission happens here, fusion happens there. It's exactly what happens in a nuclear reactor. They want to get down to these particles. These are the most intense, powerful particles that exist on the face of the planet. And if you can break those away from the black, which we did, you have more energy there than you can possibly imagine. And it has to be harvested right there. I've been asking for this for over 10 years to have somebody look into it. I don't have the facilities, I don't have the expertise to do any more than I've done. But I think if this did work, it would be a quantum leap, basically, and no pun intended, for humanity. You see this? In essence, the vacuum of space is not just a condition for the Webb telescope operation, but a critical part of its design and function, enabling its unique scientific capabilities. It has no scientific capabilities. It takes nice pictures, but as far as distances, it's worthless. First of all, they're looking through stuff like this. This is quite obviously not a vacuum. Just the magnetic fields here that bump against other magnetic fields would slow everything down. They have no idea where we are. None. Zero. And this has got to cost a lot of money. You see this? This telescope cost $10 billion with a B dollars. All right, that was just to get it launched. $10 billion. Now I don't know how much they spent since then. And it doesn't do what it's supposed to do. Its design is based on the fact that there's a vacuum in space. There's no magnetic fields. There's no light particles. It's just not correct. Okay, my friends, this has turned into another marathon, but this, I have shown, literally without a doubt, that light consists of these two particles, which they call a Dirac neutrino, and the antimatter is actually the matter part. The black is dark matter, it's gravity, it's the thing that sucks the white around it. So we have never seen the black before because it's completely coated by white until you hit below subatomic levels. When you're in the subatomic range, the white can be covered by the black, and that's the only way we were able to see it. Let me show you here. You see the black is right on top of the white? Otherwise you don't see it. The black is everywhere. Black is everywhere. Everywhere, 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 everywhere. The only way you can see it is when it just covers up the white. Otherwise you don't see that. Can you see what I'm talking about? You see how the black is sitting right on top of the white? Otherwise, you can't see it. But there's white, there's black everywhere. The only way where you can see it is when it's sitting on top of the white so the white can't hit us. On both sides. On the outcoming side, same thing. Now, the black appears to be able to sit right on top of itself. You see how that little blob is right there? And it doesn't seem to I don't think the black pushes each other apart. I think it just doesn't care about the other black. At this point, that's what I'm taking. I don't think the black attracts more black. The white attracts the black desperately, or the black attracts the white desperately, whichever you want to look at it. But the two of those, boom, they come together like that. The white pushes each other apart. They hate each other. They hate each other. That's why you get these patterns. Those are repulsion patterns. So the black is desperate to get to the white, or actually it's the white getting to the black. The black is your ground. Black is ground. And it literally is ground. It's what you're standing on. It's dark matter. This is dark matter. Because that's the thing that has the weight. That's the thing that knocked over the house. The thing that burnt up the house, as I think I showed you or will, is the white particles, these. This is burned it up, it has no mass, and it has no weight. And you put that into a battery, it fills it up, got tons of energy, it never gains an ounce. It may gain something, but they really can't find it, I don't think. All right, I've shown you Einstein was wrong. Light can accelerate. There's virtually no question about that. Not only that, he was wrong about this too. E equals mc squared, which is basically E equals mass. Energy is mass. Well, mass has weight. So any energy has to have a mass associated to it. Now he threw in the c squared, which means nothing because c squared is always the same number. It's just like saying times 1, so it's just ridiculous to throw that in there. So E is supposed to equal mass. Well, guess what? It says that means energy and mass are equivalent. So the amount of energy and the mass are equivalent. And a small amount of energy corresponds to a very small amount of mass. A small amount of energy gives a very small amount of mass. Well, guess what? When you charge a battery, when a battery is charged, it gains energy, a lot of energy, according to E equals mc squared. This is energy gain should translate into a tiny increase in mass. No. If you got a lot of energy, you should get a lot of mass. They just decide, it's just translated into a tiny increase in mass. Why would it be tiny? However, the mass increase is so small, it's practically impossible to measure with standard scales. I don't think there's any gain at all, but maybe something. They say for a large Tesla battery, that's a car that could drive, let's say 500 miles, holding 100 kilowatt hours of energy, full, from right to the brim. The mass increase due to charging it from nothing and filling it up with all that energy is estimated to be about 3.4 micrograms. That's 3.4 thousandths of a gram, which is a very small amount. Yes, the car doesn't gain any weight. It doesn't lose any weight. Basically, if it gains this much, so what? That's like nothing. How can energy equals mass if you're getting all that energy and you're putting in 3.4 micrograms of mass? This just doesn't make sense. So that's off the table too. So here Einstein, it was wrong about both of those, quite obviously. Okay, I'm just going to leave it at this. I'm getting set up here for a geek fest. We're going to go through all kinds of electrical interactions, magnetic, how motors work, magnetism, polarities, all kinds of stuff. But remember I showed you we accelerated the light, we split the light into the black and the white particles. Now, what they show at CERN and everywhere else in the Large Hadron Collider, if you can do that, you create from low energy showers into high energy showers, high energy from low energy. What does that mean? Increase in energy. And the muons, these are the muon showers, they stay back. The electron showers come through and they come into to create a shower. Precisely what I showed. And this is the same laser right here through the Venturi, very simple construction, takes no energy, crushes the fields, only allows the white to come through. If we can harvest that white right there and send it down into our battery or whatever you want to do with it, it has no weight to it. So you're really going to be putting a solar collector right there. Basically, that sort of thing. Now, there's all kinds of new perovskites and all these new thin film, transition metal, receivers, and they're not going to be out in the weather or anything, so they don't have to be any special stuff. They're going to be within a little box or something, just like this. I show this. It's a little Geiger counter, but you could have all the stuff you wanted in there to create these, and thousands of those in there, thousands and thousands in this box. And every one of them squirting out white, which is extremely energetic. You bust it down into a good size, outlet or whatever, and you just tap into it. And it's, you don't have to have this in some grid or anything. You just walk around with it, plug it into anything you want, click your dial or touch your little buttons or whatever it's supposed to be, and you get the electricity you want. 50 cycle, 60 cycle, you get all these kind of little regulation devices in there. Very simple. It's just off-the-shelf stuff. This is nothing you even got to think about. It's all done already. We just need to get something in here to harvest it, create a good thing, and nobody's going to patent this now, except maybe Rod Warren. He's the one that did it. He just did it by accident. But as far as I know, I don't want anything myself. I don't know if Rod, I haven't heard from him for years. So I think he just wants to be out of it, but I'd like to see him get credit for this, because otherwise I would never know this. When I saw what he was doing, nobody knew it. Everybody looked at it and just said, "Whoa, what is that?" Well, I knew what it was right away. I could tell. According to Dipole Electron Flood Theory, I knew what it was. There was no going back from this. It's just being avoided now. And I show you, we can go, light goes 2 different speeds, it will go 3, 4, I don't know, all kinds of different speeds. Now the red, the blue, and the green, I'm not sure whether that's just the result of because of the crystals in the lasers, or whether that's actually something that, we have to deal with, as those are the actual frequencies of light that are natural. And you see them coming down, the red and the green and the blue and the, cosmic aurora borealis and so forth. So is it just because of the molecules that are in the air, the oxygen or something like that, and the speed of the particles hitting the oxygen molecules? And I'd like, because different gases give off different colors. There's a lot to discuss here. This is not something simple, but I can tell you what, this is not supposed to happen, this barrel rolling like that. Not supposed to happen. That's always supposed to be an upspin or a downspin, but it's always polarized towards the Earth. That's a barrel roll. That is extremely, well, you never see this until you put both of them through, separated like this at the same time. Otherwise, you just see debris, which is just chaos, yes. But in this case, we can actually see the particles themselves, because this wasn't tuned enough to separate the black from the white. These still are particles. All right, you got to tune it a little bit tighter to separate and only let the white come through. So this is letting the entire particle come through and spin like that. And you don't see the black, because you're never going to see the black. You never ever see the black unless it's sitting on top of the white, and we don't have the white here. All right, I'm leaving it at that. Prepare yourself for the Geek Fest. And if you got kids or you know somebody that's interested in physics, and because we're going to get deep into this, as deep as you can get. I did all this stuff my whole life. I understand this stuff as well as anybody, and I'll talk to anybody about it. It's obviously I have gaps in my knowledge, which is why I ask. I reach out to people to tell me, what do you think about this? Let's talk about it. And I think I have it to a point now where I pretty well understand what's going on. And I do understand these particles, which we found, which are the same ones they find at CERN and Fermilab. This is directly from Fermilab. And these are the particles we found. And this has been going on for a very long time. This is 10 years ago that I contacted Fermilab about that, and because of my intrusion into their space, I have been blocked. Now, their space we are paying for, so I think this should be taken into account. The same thing with the research on Bennu. They can't accept the results. They're looking for these answers. They're asking for people to answer things, and they will not respond to the results of the answers, because the answers change what they have been taught to say, literally. It's an echo chamber now. If you don't say what you're taught to say, they will literally destroy your life. They'll say you're an idiot because you couldn't repeat what you were told to say. All right, I'm going to just leave it at that. I go down this road every time, but that's the condition we're in right now. And I don't see Trump and Musk moving into where they should. They should be talking to me, and so should Robert Kennedy Jr. about fecal matter transplants. We need a whole new way of thinking. A whole new way of thinking. All right, I love you all.